percent of the table size, then the optimizer may decide to use a full table scan. So the optimizer may not use existing indexes of that, on that table. The optimizer may decide to go straight to the table and retrieve the data. So this formula is just for the data that should be returned to the user. That is how the optimizer thinks. And it makes sense.
Yeah, that was my argument. But the other person was bringing another argument that, like you just earlier mentioned, that if the result is like, if the result will be 1%, you probably should use an index. So I was just wondering, like,
you are not the one to use the optimizer. All this is are what are happening in the background. It's not like you should use. The optimizer will decide. This is how the optimizer thinks. It's not like you are deciding. If you want to use an index, you want to force an index to be used, that's something else. But if you want to leave Oracle to handle, all these things for you, that is how the optimizer will be thinking. Okay, so everything depends on the optimizer. He will calculate the cost of using an index, and he will calculate the cost of performing the full table scan, and the optimizer will just choose the cheapest option. That's it. You don't decide, okay, as the end user, you don't decide. If you want to force, then we can force the optimizer maybe to use an index or to perform a table scan, a full table scan. But if you don't force the optimizer, based on the statistic that the optimizer has, is going to choose one of those options, either to go to the table straight or to choose an existing index created on that table.
Okay. Yeah, okay, thank you.
All right, no problem. Questions, please.
Excuse me, can you go back over to list partition? I think page 14. The first one and then the last one. If you can go back just a little bit.
Okay. So I don't want to specify all the details. So I'm just taking time to explain the list partitioning. As I was saying, I said that list partition occurs whenever you are taking a column as a partition key. So that means my partition key here, for instance, is state. So this column is what I will use for my partition, okay, to partition. So meaning I have a table and I want to split this table into multiple partitions. But I want to use the list partition. I want to partition all these people by state. Okay. Where is the cursor? I'm looking for the cursor. Oh, I cannot see that. Where is it? Okay, good. So I want to partition all people by state. So meaning that I want all the employees. I just listed 5 of them. Okay, let's assume this table has million of records, and you have, these 3 states: California and Texas. Okay, so it means that I want to partition by list because I have the list of value. This is the first value, this is the second value, this is the third value. So I will say that, okay, I want all people who are, okay, who are from Maryland to go in one partition. It means that on one partition, I will have a table like this: first name, last name, security, state. So I have a table. If I want, for instance, only people from Maryland, I will have, for instance, based on what you guys can see, right? I will have only 2 employees for Maryland on that table. So meaning for Maryland, I will have only A and D. Because this is a partition, for instance. Because I will divide this big table into sub-tables, okay? Small chunk of tables, okay? A table is smaller size. But now I will divide them, I'll partition them by state. So meaning everybody those who are from Maryland, we go in one partition. Those who are from California, we go in another partition. And those who are from Texas, we go in another partition. Okay, so this is partition by list because I have a list of values. This is the list of values. So meaning when I'm creating this table, or I can update this table if it's already created. While I'm updating or creating the table, I can specify if I want to partition by list. When I specify partition by list, I specify the partition key, which is the column. I will specify the partition key, and now I will list all the partition with with the values, the different values. So this is the list of what I want to partition. Okay, and all those each partition now will be created based on these values. Does it make sense?
Yes, thank you.
Do you understand partition list partitioning?
Yeah, I got you.
Okay.
Which one? Okay.
Yes, you have a question on list partitioning again? Someone has a question on list partitioning?
Yeah, I have the question about a partition list.
Okay.
Yeah, I don't know the criteria you use to get the partition key, the partition list.
What you need?
Yeah, I want to know how about a partition key.
Okay, you are the one, okay? The developer is the one to determine which column is best to be used. That's why it needs testing.
Mm-hmm.
In general, we use frequently accessed column as partition key. Okay, so we can decide. There are some type of column we cannot partition by list. Okay, a column like social security, you cannot partition by list as well because everybody will have different social security. So that means if I have 1 million records, we have 1 million different social security numbers. So it doesn't make sense. Okay, so again, yes, the criteria for partition, to partition by list, can mostly be stuff like region, state, countries, and so on. Okay, so those columns where multiple people can belong to multiple, because we know that multiple people can belong to the same state. Okay, so it depends on, the type of column. And I gave you some of the common one. The common one, the state, the country, the region, okay, the race. Is it an African American or Indian or Spanish or whatever, Hispanic, all those stuff. It can be determined depending on the table structure and depending on the column that are created on that table. Okay, So, but there are some columns that can never be used as partition key. We cannot use first name as partition key because in a if we have an environment of 1 million customers, maybe a maximum of 10 of them can have the same first name, but it won't be like you have multiple people, okay, who are having common first name. So column like first name, last name, social security, date of birth, all this stuff, they might not be used as partition key whenever we are coming to list partitioning. List partitioning is basically whenever we have, we know that if somebody doesn't belong to this region, he or she should belong to the other region, okay? Or if you don't belong to this country, based on the key we created, you should belong to the other country. So that is basically how it is. So it mostly goes with state, region, country, and maybe continent, okay? Continent, America, Africa, or whatever. So those are the common values of the list partition, the common type of column.
Okay, thank you.
All right. The other type of, which one was it again? Composite?
Yeah.
Okay. So composite is just a mixture of, one composite can be, it can be list. So that means you have list partitioning and you have list. It can be list range. It can be, list hash. The other matter, and it can be, it can be list hash. Now it can be range, list, and so on. Range, list, range, and so on. So it's just a mixture of of multiple partition. It means that, let's assume that we are taking the same example, a partition by list, okay? And now, for instance, we have 3 states. That means we should have 3 partitions, correct? A partition with people from Maryland, other partition, people from California, another partition, people from Texas, right?
Yes.
Okay, now, even the partition are still big. So let's assume that a table is terabyte of data. Even after you partition, maybe this table is still more than 100 gigabytes of data. So in that scenario, it's still big. So you can again partition this table now, maybe by list or range or hash. So it's like you're partitioning an already partitioned table. Does it make sense?
Yes, but I think the range you say last time, you say this partition is basic by the number.
Yeah, okay, yes, you're correct. That one is totally different, okay? If you want to partition by range, you will not use state or social security. Does it make sense? If
yes.
this small table has a column time or date, then or age, it makes sense. Does it make sense? So you can partition by range. Maybe you can say, okay, from 90, from 2000 to 2005 and so on. That's a range of value, okay? So that is in case the sub-partition also has a column, date or time or whatever, okay? I'm not saying that the same partition key should be used for another partition method. So if state was used as the partition key for the list partitioning, and now you want to partition again the sub-partition, it's not mandatory for you to use state, okay? If you have another column, that is date, you can partition now by range or by whatever you want. The partition key can change. It's not mandatory for you to use the partition key whenever you're using composite partitioning. Does it make sense?
Yes, sir.
Good.
So can I just clarify? So if I wanted to partition the phone number, would that be like a range partitioning according to like the area code?
If you want area code, that is different. Does it make sense?
Okay.
Area code, the area code now, maybe we can say, okay, the area code can be used as list. Does it make sense? Can be used as list because multiple people can have the same area code. And it makes sense.
Yeah. So that would be list partitioning.
It can be list. It
Okay.
definitely be list, okay? Unless you want to, unless you can use that one both as list or range. It's possible to use as list or range, okay? It depends on how many records you have on that table. It depends completely. Because if you see that more than 10 people on that table or more than 20 people on that table have different area code, why should you create a list partitioning? Because if they are having different area code, okay, that means if you are partitioning by list, it means for every single area code, there should be a partition. It means that if you have 20 people who have 20 different area code, it means there should be 20 partitions. I don't know if it makes sense in this scenario.
Yeah, in this scenario, yes, but in a different scenario, it could
Now,
make
for this particular example now, because I have 20 people, okay, with 20 different area code, and I don't want to partition by list, I can decide to partition by range. I can say, okay, from area code 202 to 240, one partition, okay? I can now do it by range. Does it make sense? Range them. Maybe all the area from 2 to 3, all the area code starting with 2 and 2 to 3, I will create a partition. Another area code from 4 to 5, another partition, and so on. So that all those people will have, you know, you are partitioning now by range, no longer by individual area code or list. We are now doing a range partitioning. Otherwise, we have multiple partitions that have to be created. Does it make sense, what I just said?
Yeah, thank you.
I hope it makes sense. If it doesn't make sense, please let me know.
No, it doesn't make sense.
It doesn't?
No, yeah, I don't understand why, how it can be a list partitioner and a range partition at the same time.
Again, that's what I'm saying. It depends on what you want, okay? I'm not saying it's at the same time. I just say that it won't make sense. It won't make sense if, okay, if we have more than 20 people or more than 10 people who have different area code and you want to partition by list. If you want to partition by list, it means that for every single area code, there should be a partition. That is what it means. So it means if I have this area code from this area, different area of maybe Maryland or whatever, you have 20 different area code. It means that for each area code, you have to associate users. So meaning you are creating partitions for every single area code. So it means that if I have more than a lot of people with different area code, it definitely means that they will, we have multiple partitions because we have a lot of people with different area code or more than 10 different area code. It means you have to create more than 10 partitions if you want to use list. But if I don't have a lot of people with different area code, if maybe all of them have maybe 4 area code, all of them are using maybe 4 area code or 5, then I can create partitions by list. Because I don't have a lot of area code, I know that I will not have a lot of partitions to be created. So I can just create the 4 partitions, and I know that those 4 partitions will contain all the users.
Okay, I get it now. Thank you.
Yeah, no problem. Questions, please. Questions.
Can you go a little bit on the page 17? It says optimization levels. We're really a little confused about those levels, like it says first row N, and all rows.
Oh, you mean this one?
No. Yes.
Yes, this is just, by default, this is the default optimization mode you guys use. It means that whenever you guys issue a query, by default, the entire result should be returned at once. If you guys issue, for instance, select all from scott.emp, by default, everything should come up, right? Everything, all the results. So that is what you guys use by default, all rows. That's the optimization mode, all rows. That means all the rows should be returned at once you issue a query. But when you issue first row, if you change the optimization mode to first row, alter system set whatever optimization underscore mode issue first row, or you want to add a hint, or you want to do at the session level or whatever, define to first row, it means that when you run your query, only the first row will be returned to you. If you want more, then you hit a key and the next one will be coming. So it depends on how many rows you want to be returned. If you specify first underscore row 10, it means 10 rows will be returned to you at once. If you want additional information, you can get it. Because sometimes we have some users, maybe whenever people want some report, when they have maybe just the 10 first values, they are okay with that. They don't need to check other informations again. Okay. So that is why you can decide to change the optimization mode to either of this, depending on whatever you want. Does it make sense?
Yeah, it does.
Questions? Questions, guys? Okay, if you don't have a question, I have 5-minute question for you. Okay. Tell me anything you know about indexes, benefits, disadvantages, and so on. Someone to try, please. Know about indexes. Who wants to?
Indexes are used to speed up sequence statements in the database.
Yeah. Speed up sequence to the database.
So an index is a database object. They're considered database objects that improve the performance of queries by allowing faster retrieval of data. And they are logical objects. An index is usually automatically created on large tables and can also be added when manually creating tables.
How do you automatically create it on large table?
That was my question.
Okay, I guess what I mean is some like when we create like those tables that come to us, or those schemas that come to us already with the software, like the HR tables, they are automatically created.
Okay, so there's a difference between whenever a table is bigger and an index automatically created, and whenever that was done by design. Okay. Yes, they can be, while designing the table, they can create an indexes on those tables while designing, but index doesn't get created automatically unless the column is a primary key column. If the column is a primary key column, I don't care whether the table is small or big, Oracle will automatically create an index on that table. Okay? But apart from those type of columns, you have to create an index on those tables manually. You are the one to decide. The developer are the one to decide, okay, we need an index now to speed up the query. queries in the database. Does it make sense? It doesn't get created automatically on any column. Does it make sense?
Yeah.
Yeah. Okay. All right. So yeah, you gave a lot of good information. What are some disadvantages of why using indexes? Drawbacks? Are they just advantageous? What are some disadvantages you know when it comes to indexes?
I think one of the disadvantages is when you have like stay statistics in the database. That kind of like makes the index not useful. Let's say like for example, like if you have like a textbook, you go in the front, you see like the index, maybe like page 25, there's like let's say backup and recovery on page 25. Then for some reason that page 25 is torn, but on the index it still say that page 25 has backup and recovery, which in the textbook is not. So that makes it like, the statistic in the database doesn't correspond with what is on the index. So it makes it kind of like slow performance.
Yeah, definitely in that scenario, definitely there. Yes, and in that scenario, the index is there and it is quite useless, right? It's not helping you to get accurate information or get what you want faster. Yeah, it makes sense. This one. What else do you know about indexes? What other
Indexes.
I think another disadvantage of an index is when a column has an index. When you're doing a query and a column has an index, you'll go for that column, that index, versus doing a full table scan, which could be faster.
Okay. That you are saying that on your query, you specify an index column on your query, maybe on the workloads, and you want your query to use an index. And what you're actually saying is that the server process decides to use an index instead of going for a full table scan.
Yes.
Okay.
Where the table scan could be faster than using the index.
Okay, if you give the choice to Oracle, Oracle will choose the full table scan if Oracle judges full table scan to be faster or to be more efficient. And again, I told you guys that faster is not actually what makes a query be a good query. Okay, the speed is not what makes a query be a good query. It's better. Oracle will choose a query that can run slower, that doesn't run that's not that fast, okay, but using less resources than a query that runs faster and uses more resources. Everybody in the system are sharing the same resources. It is like we are in the classroom, we have a certain amount of seats, okay? Everybody, all of you guys are sharing the same seat, you are sharing the same classroom. So it means that if we don't have seat anymore, what will happen? Those who are coming late, they have to wait for one of you guys to leave, to go home, okay? Or they will have to wait till the end. That is how it works. So whatever we call CPU, processing power, everybody shares the CPU. So we cannot allow one person to take more resources than others. It is like you get to in class and you have one person who is taking 5 seats for himself or herself. Maybe you put your bag on one seat, you put another thing on another seat. So what about, it could have helped 2 people, right? It could have helped 2 people actually to use that seat to be more comfortable to follow their course. So that is the same example with the Oracle. So for Oracle, a good query is not a query that runs faster. You can run faster, but you are using more resources. You are preventing others from executing, okay, their code, because you are there taking all the resources just by yourself. And that's not efficient for Oracle. So Oracle will better choose a query that has, a moderate speed, but uses less memory or less CPU. That can allow other queries to also use some memory and some CPU to be executed. That one is by default how Oracle behaves. But you, the GBA, you can decide to set what we call resource management. If you want to prioritize some type of queries, if you want some type of queries to always have more resources, then you can do what we call resource management. And I will throw more light on resource management when I will be talking about rack services. That is the last project we'll be working on together. So, or even on 12C, I will talk about on 12C even. 12C, after this performance tuning, I will throw more light on resource management. So that is in case you want to prioritize some job. Let's assume you want to say, okay, all the six user job, I want to prioritize all those jobs. I don't care whoever is connected to the database. Whenever the 6 user is connected, I want the 6 user to have 60% of the CPU of the system. The other people will share the remaining 40. In that scenario, 6 user can be greedy. It can use up to 60%. Okay, that is how it will be. But if you don't set something like that, a query will come. If that query you need more resources, the query will just use even 90% of the CPU. And it's not a good query because it will cause a lot of wait events. So don't judge a good query as a fast query. A good query is not always a fast query. A good query is a query that uses less resources, less memory, less CPU, and perform less I/O. Less I/O means what? It doesn't go to the disk frequently. That is what is a good query. If my query can get the maximum amount of blocks from the memory, it's a good query. If my query can use less memory, okay, the memory allocated right on the SJ or query. If my query can use less CPU, it is a good query. So that is how I want you guys to be thinking. So in case now the optimizer sees a query that is coming, and that query is using more CPU, but it's faster, it's not guaranteed that the optimizer will choose that one. Instead, the optimizer will go and check the query that is using less CPU and is having a moderate speed. Does it make sense? So Oracle will do that automatically. It's not, you don't decide. If you want to force now Oracle to use an index, it's something else. You can force using hint or whatever. Does it make sense?
Yes.
Questions? Okay. Yes, some other disadvantages of using indexes, I told you guys that whenever you are doing, you are issuing GML, instead of a select, you are using GML, Oracle has to rebuild the indexes, reconstruct the index, and that is very expensive, okay? It's quite expensive. And over-indexing can also confuse the optimizer. Over-indexing means if you have a lot of indexes on the table, the optimizer has to take all of them into consideration. Let's assume you are issuing a query and you have indexes on that table. That some of them are not even are useless. They are there, they are not even helping because you contacted advisors and they told you to create indexes. You are just creating indexes, adding indexes. And at some point, the optimizer now, while it's trying to create a plan, while it's trying to create a good plan for your query, you find itself going across multiple indexes to pick the best one. So and by doing that, we push the optimizer to stay longer or to take longer in order to create a good plan for your query. But if instead we had smaller amount of indexes, now the optimizer will have fewer options to create a good plan. Okay. In case you have multiple indexes, and some of them are not useful for now. Maybe you think that in the future you can use them. Just make them invisible. By making them invisible, the optimizer will not even consider them, see them. But whenever you need those index back, just make them visible. The optimizer now will consider them whenever it wants to make, okay, its decision. So over-indexing is not a good thing, okay? So that's why we don't give the responsibility to create indexes to whoever wants to, okay? So whenever there's a need for indexing, it has to go through testing. Whatever has to be kept as index will be kept. Whatever has to be removed will be removed. You don't want to affect the performance of the database because of a lot of indexes created on the table. Yeah. Okay. Let me answer this guy. Give me 1 second. Okay. So for today, we will proceed with something else. I think we stopped at explain plan and education plan. I think we stopped here last class. I think I gave some differences. I took the example of GPS to explain, the explain plan and education plan. Okay. So today, okay, I will come back a little bit on statistics and we move to the way of generating the explain plan, education plan. So as we said, when we were talking about histogram, we said that by default, the optimizer uses two statistics, system statistics, optimizer statistics. And we said that system statistics, are just information at the system level, like, in case, we increase the CPU on a host, or maybe in case we add a new disk, in case we increase the memory and so on, we want the optimizer to be aware of that, and this is how we can generate system statistics manually if you want to. But by default, in any environment, I cannot say it's 100% everywhere, but all environments I work for, automatically these statistics are gathered, and they are gathered frequently, because they don't use a lot of resources. It's a quick job, okay? So this system statistic, there's a job that will be scheduled in your environment, and that job will come and gather, and we gather this information frequently, okay? Once it is done, you will just do the stop, because this is start. That job will just, on a share script, okay? We will create a script, a share script, and it will be scheduled, okay? So with the share script, we have start and stop. So we start, and after a while, it stop. So if you want to view them, you do this command, issue this command. And the other one were optimizer statistics. We talk about optimizer statistics. And these are some level of statistic gathering. You can decide to gather optimizer statistics at the database level. Or you can decide to gather them at data dictionary level, or schema level, or table level, or even index level. So when you decide to gather database level, you will gather for all the objects in the entire database. So it means that this one will take longer than any other job. But you guys have to know something. I made mention of state statistics, right? That state statistic means by default what you guys learn. It means that the data on the table has grown more than 10%. That one also depends on the table size. If I have a table of 40,000 rows. Okay, 10% is fine. But if I have a table of 40 million rows, even 5% is a lot. So even 5% is to be considered. Does it make sense? So it totally depends. When you talk about statistics, it depends a lot on the table size. You guys have to know that. So we're talking about statistics, okay? Don't think that whenever we say that the table has grown or changes on the table have been performed more than 10%, or maybe the table has grown more than 10% of its size. It doesn't mean that those 10% or more have been performed maybe just one day. In rare scenario, it can happen. So don't think that because we say optimizer statistics are gathered every 24 hours, maybe they were gathered late yesterday at 11 p.m. It doesn't mean that if we are talking about statistics, the table growth occurred only today. Why am I saying that? It's because this statistics gathering job has low priority over most of the job in Oracle. So it means that whenever this job is running, Oracle gives less priority to this job. It means if another job is running in parallel and the other user job needs more resources, Oracle will stop this job and take the resources allocated for this job and give it to another job. So that is why sometimes you can even find some object statistics that have been gathered 2 weeks ago or even a month ago. So don't think that because we said they are gathered every 24 hours, it means that all the object statistics are gathered every 24 hours. Let me tell you how it works. We set a window maybe of 2 hours, 11 p.m. to 1 a.m. When we set a window, it means that after 1 a.m., that job should not run again. Now, the job started at 11. It is running. At 11:30, maybe there's a user transaction taking place. Maybe there's a data pump job that was scheduled to run. Maybe there's a patching, any job that was running, that was scheduled to run at that time. That job needs more resources. At that same 11:30, if the other job doesn't need more resources, it's fine. Oracle will proceed with both. But if that job needs more CPU, more memory to run, Oracle will stop the statistics gathering job and all the resources of that job will be allocated to the other one. So it means, and after 2 a.m., after 11 a.m., after 1 a.m., sorry, because the window is due, right? It's due at 1 a.m. because it was 2 hours window. So after 1 a.m., the statistics gathering job will not resume. It won't resume. It will wait till the next window. It means that whatever object statistics that were not gathered, the next day, it will not start from those ones. No, it will start again from scratch. And how is it organized? It starts from the more important object to the least important object. The more important objects are administrative objects, objects found on system tablespace, 6aux tablespace before we go to users objects. So it means that maybe Oracle gathered system data, but once it was getting to application data, it stopped because Oracle has to get those resources and give it to another job. So it means the next day again, Oracle will start again from the system statistics, or from the system tablespace again. If it has the chance, it will gather for everything, and so on and so on. That is why for some objects, you will see their statistics are very old. So when you are talking about state statistics, it could have been that statistics on that table have not been gathered, haven't been gathered maybe for 1 week or 2 weeks. But the table was going through changes. The table was data was, users were adding data on the table. Users were deleting data on the table. users were creating indexes, but the optimizer is not aware of that because the optimizer is relying on those old statistics. Okay, so that's what you guys should know. Okay, about this job. So I gave you a query. I gave you guys a query on this. If you want to see, for instance, the last time statistics were gathered on a table, I think as I specify select, if you want to specify table name, last analyzed. If you want for the table, you specify GB_tables, table name, you know the table name, maybe it's HR.employees. Go and issue a query like this. If it's for indexes, you specify GB_indexes. If it's for column, if it's for a partition, okay. If it's not for the entire table, you want for a partition, you replace GB_table by GB_tab statistics. And so if it's for column, you specify this one. If it's for clusters, cluster is just multiple table, put together. And I will explain this one when we get there, and so on. So you just change maybe the table name, but this is an example of the column you need to check, the last analyzed column. Okay, this view is very important. So this one will help you to see the last time statistics were gathered. So even on your database, you can check. You will notice that the table you are using, some of the statistics have been gathered for 2 weeks, the past 2 weeks or the past week, even though there's a job that runs on Bronze Tech every 10 p.m., but those statistics were not gathered. So that is what it means, basically. Now, let's go to the different way of generating a explain plan. Sorry, I was trying to reply to this email. I just received. Yeah. Yeah. I think one second. All right. Okay, so any question about the statistics gathering job I made mention of? I think it makes sense what I said, right? I hope it makes sense, or any other concern.
So is there a way that Oracle can make it in such a way that like you say, if the statistics were not gathered because maybe like another more important job was running, is there a way Oracle can make it like when it comes back to the next window, it will start from where it stopped, other than just like starting all over?
It's even worse because the data dictionary should have all the information. Let's assume that you want Oracle to start from the object before it goes to the administrating table. So it means that if maybe some rows were added on the table, okay? So you want, how will the data dictionary be aware of that? How? That means you are not starting with system table space, right? You are starting with another user's table space. But you want Oracle to be aware of the fact that maybe today, maybe you gather that information, okay? Yes, it's good. But you want this information to be present on the system table space as well, or to be recognized by Oracle. You want Oracle to use this information. You want the optimizer to use this information. So just to say that Oracle has its way of working. Okay, if Oracle tells you I'm prioritizing administrative table space, Oracle will prioritize that. Because if those table spaces are corrupted, if the data on the data file header of those table spaces doesn't match what is on the control file, Oracle will stop working. That is corruption. So that's why Oracle always prioritizes first critical tables, system tables, then before you can try to figure out what is wrong with other objects. Okay, so when it comes to what you can also do if you want that job to always run till the end, just do what I call as resource management. Okay, resource management, it just means that by default, okay, that job, I just said this statistic gathering job, also with Arman backup job, all those jobs are stored belong to a particular resource group. A resource group is basically a group of resources. So you create groups, that is part of the database resource management. So you create groups, and to those groups, you give them a certain amount of resources they can use, a share of resources or a certain percentage of resources. Let's assume I create a first group called admin. And to that group, I give 60% of CPU. Another group, I create the group, I give 30%. And then the last group, I create maybe maintenance. And maintenance, I give them 10%. By default, backup jobs are among the last group because we don't give backup job. See, they are very heavy, right? They take a lot of time. We don't give them a lot of priority. So we also put them in the maintenance group sometime. So if you want a job to be completed and to succeed, okay, or to run faster, you can move that job to a higher group, a group with more resources. That scenario, the job will have more priority over some other jobs. In case you think that your job is very important, you can just do like that. So you create, either you create a new consumer group or you move that job in another consumer group with which has more resources allocated to it. Okay, you can do that. But when it comes to reverse the order of how Oracle can behave, I cannot tell you another one. Maybe it's possible, but I cannot tell you it's right or not. Does that make sense?
Okay, thank you.
Okay.
That's a question.
Yes, please.
You mentioned the system statistic are gathered frequently. How frequent?
It depends on the window is set up for that. You can decide to gather that every 15 minutes.
Okay.
Every 20 minutes, every whatever. But it's something that should be gathered frequently. So it should not take hours to be gathered than like automatic statistics. So it depends on you as well, okay? It's not like by default we run every this. And say every 15 minutes run, every 20, every hour, it depends on you.
All right.
So now these are the different ways of getting the plan. I talk about explain plan execution plan. So this method, I'm sure 100% that if you are working as Oracle DB, you will use at least 2 of these. But I will go through each of them, okay? And when we come back from break, I will do that on SQL Developer or SQL Plus, okay? So just go to the theory and we come back from break, we do the practicals. Okay. So I will go to the first one. The explain plan for is one of the ways of getting the explain plan, not the execution plan, explain plan. So it means that it's easy to use, okay? You just use explain plan for, then specify the query at the end. As you guys can see, just put explain plan for, you put the query at the end, whatever select you want, whatever you want. And right after that, you run select all from table, whatever. So whenever you run the first one will just give you a result like explain. That's it. You will not display anything else. But now you have to run the second one for it to be displayed. To display the plan now. To display something like this. To display something like this. Looking like this. You have now to run the second query, which is GBMS explain display. So this plan is, this one will give you the explain plan, as I said, okay? But it will not give you the execution plan. It will not give you up-to-date information, okay? Okay, so it will just give you the plan or the prediction, what was predicted. The prediction can be equal to the execution, to what was executed, but it can also be different. So it's not something that reliable, okay? I will not recommend you to figure out the plan of your query using this way, this option. It's good to know, but don't take this as the option you should use to find out, the plan of your query. So, and I say this plan, you just display the plan, okay? This query displays the plan, but the plan itself is stored in what I call the plan table. Okay, so if you want to see the plan, this plan table contains all the plan of the database. But the plan table is also maintained, okay? It's not like those plans are persistent. It's also managed like the LRU. So old plan will be flushed out, okay? Old plan will be deleted and only the new plan will stay, or the frequently used plan will stay, okay? But if you want to get the explain plan, you use this. You put first explain plan for, you specify the query, and then you just put select all. Just run this query as it is. Don't change anything on it. Okay, we will do that a couple of seconds. It's very fast, very easy. Another way of getting the explain plan, we will do this one as well on the SQL developer. Another way of getting the explain plan is auto trace. Auto trace, can also help you to trace a session that is actually there, to trace a session. So it means that if I set auto trace on, it means that anything I will be running after the command will generate an explain plan. If we can remember, when we were doing histogram, when we were talking about this query, right? Remember, someone asked about this, how I got the plan. So for instance, I set auto trace on explain. So when I set it on, every sequence statement that I will run after this, we generate either the result and a plan. Every single statement, okay? Every single sequence statement we generate a plan. Even if I select name from video database, it will show me a plan. So this is another way of getting a plan, but make sure that when you set it on, you run your query, later on you have to set it off. You have to set it off, okay? So it's like this example, I set it on, and I run the query. And you can also set it on this way if you want only statistics and so on. And then make sure that at the end, you set it off. The meaning of each of the metric, auto trace, statistics, whatever, you go to the comment of your PowerPoint, you will see the meaning of each of them, what they mean, what they will return. You can even try yourself. You try some of them, but you as well, I want you to type the keyboard. Try. Okay. So auto trace is also okay, can help the explain plan, but this is another like the previous one. if you are using bind variable, the auto trace may not help you. I don't know if I have a PowerPoint on bind variable here. Yes, I do have. And I will explain what are bind variable basically when we get to that level. Another way of getting a plan is using a GBMS X plan cursor. This one gives you, I will no longer say the explain plan, but the execution plan. So meaning this one is a bit more accurate than any option I showed you guys earlier. That means explain plan for or auto trace. The third option is better. And this is highly used by GBA. By force, you should know how to use the GBMS X-Plan cursor. You should also be able to say that in an interview room as well. So because this is frequently used by GBA. So it looks similar, similar to the previous one. You can still see GBMS X-Plan display. GBMS X-Plan display. But the other one, there is display underscore cursor. So it means the other one is at the level of the memory. So it's more up to date than the other one. So this one is more up to date. So it gives you more accurate information than the previous one. So, and to get this one is also easier. So you should get this, you should run this after the query has also been executed. So after, so the query has to be executed first. And once the query is executed, you should get the SQL ID. We all know that every single SQL statement in the database has a unique identifier called SQL ID. So it means that you can use this query to get the SQL ID of any SQL statement if you already have the SQL text. The SQL text, the text, the text. This is the text, for instance, okay? Text part of the query. So once you can have the SQL ID, then you will just run this query. You specify the SQL ID, and you will get the plan. So you just need the SQL ID of the query, and you just run this one. Okay? Run the SQL statement, and that's it. Okay? All right. So I think this one, we also run this. Okay? So this is another way of getting the. It's more accurate because this one is give you the execution plan. As I give you what really happened at that time, and you can query that through the video SQL plan. It's not in the plan table; it is in the video SQL plan table. Another option to get the plan is the real-time SQL monitoring. This is a powerful tool you guys will be using if you are working on any Oracle database. I can guarantee you as well that more than 90% of the time, you will be dealing with SQL monitoring. SQL monitoring actually keep track of any SQL statement that's actually running. So it doesn't need to wait for the SQL statement, to be executed. Why a SQL statement is running? If somebody tell you, my SQL statement is stopped, SQL monitoring can see in real time what is actually happening to that SQL statement. So that is why it's real-time SQL monitoring. And I like it because whenever I was dealing with OEM, I always troubleshooted my slow running queries through SQL monitoring. It gives you a graphical image of all the SQL statements that are running and how long they are taking. That is graphical. So you can see how long every single SQL statement in the database is taking. So if somebody is telling you, hey, my SQL statement is taking, you can confirm from there. You can confirm how long it has been taking. You can now directly see the plan of that SQL statement there. So because we don't have cloud control here, I will do that on SQL Developer. And the same, it look alike. That's exactly how it is as well, okay? So whatever you will see on SQL Developer 18.2 will be the same exact thing you can see on OEM, okay? I cannot say, but with a licensed product, you can have more metrics than what I will display. So that is one of the drawbacks. You need a license, okay? You need a performance tuning package license. You need another pack. In addition to the Oracle, you need a license, a tuning pack license in order to get this, in order to be able to use this and take advantage of all the features. So this is a very useful tool, and we'll try to see that as well on SQL Dev. But it doesn't track. By default, it doesn't display SQL statements that are running less than 5 seconds. It doesn't track any SQL statement with the execution time, okay, lower than 5 seconds. So it means if you run your query and it is 1 second, SQL monitoring will not display that. But if you want it to be displayed, despite the fact that it hands less than 5 seconds, it hands for less than 5 seconds, you can use a hint. And because we don't have big queries here, I will use a hint and I will display that. And you can query as well if you want to do that in a command line, Videola SQL Monitor or Videola Plan SQL Monitor. So this view can help you. So this one is also very important to see in real time the execution plan of any single SQL statement database. It's very good. And the last one, before we take questions and we go on break, the last one is the SQL Trace and SQL Prof. And SQL Trace and SQL Prof, are also very useful. But it can also be used to trace a session that is actually running. So it means that you can decide to trace a session, and let's assume that somebody told you, oh, my SQL statement, okay, it cannot track a SQL statement that's actually running. So it means if the SQL statement is stuck, unlike SQL monitoring, SQL Trace, you have to kill it and start over. So it means that, let's assume somebody called you and say, hey, my query is hanging. You say, okay, let me track your session, okay? You just need to get a session ID. You guys know how to get a session ID with Videola session. You did some locking mechanism on GB1. So once you can get the session ID, or the person can give you his session ID, you can enable the tracing of his or her session. So once you tell the person to stop, to kill the query, you enable the tracing and you ask the person to run again the query. So once you enable the tracing, whenever the person will run the query, okay, automatically a trace file, it will trace the person's session. So whatever query the person will be running will be traced. And it will be traced and it will go into a trace file. And that trace file is found on the alert log location. So this is how you can know the location of the alert log. So now, once you trace that session, okay, it generates trace files now. So whatever the user will be doing, a trace file will be created and it will go to the alert log location. But now what happens is that trace file won't be easier, okay? It is readable, it's in English language, but difficult to understand because instead of having more graphical stuff or tables, it can display everything as raw and so on. So you won't understand it, okay? So SQL Prof now is that tool that can help you now to easily decrypt a trace file. So to make a trace file in a more readable format, okay? So, and once a trace file is generated, you just use SQL Prof, you put the name of the trace file that you saw there, and you put a new name. So you want to rename it, you put a new name. These are additional metrics. So those who are presenting a explain plan should talk about SQL Prof SQL Trace. They should generate it as well, okay? Another benefit of SQL Prof is that despite the fact that you cannot track, whenever you enable tracing, please make sure after that you disable it as well, right away. These are multiple ways of enabling tracing, multiple options. You can trace a session using DBMS Monitor. This is to enable, this to disable. You can see here, one is enabled, another one is disabled. If you want to disable session tracing, you do this. If you want to enable, you enable the first one. This one is to trace the entire database. This one is to trace your current session. So whenever you do after session set secret trace equal true, you are tracing your own session. If you do false, you are disabling the tracing. Okay? This is another way of tracing your own session again. Okay? This is another way. So you can issue either the first one or the second one. Okay? And this is another way again to trace another user's session or another session. So, but the most recommended option to trace is the DBMS monitor. Than any other one, these are the best option to trace because it provides more statistics than any other one. Okay, because tracing can help you to get more details, like you can know who is holding the lock. You can know who is preventing you to execute your query. You can have more information than any other tool are listed before. So that is why whenever we want to perform root cause analysis or we want to perform some deep researches, we will go with TicketProf because it can give you more resource, more information than any other tool. It's not frequently run. It's not frequently used because trace files are generated. They use space, and it takes too much time to go through all this process. To create a trace file, to use TicketProf to open the trace file, it takes time. That's why it's not frequently used. So if you see we use it, it's because we want some fine-grained information about what went wrong at a particular time. That's where we can try to use TicketProf, but it's very, very useful. And you should know at least how to create it. Okay, and once the group that present, we can take time to to show you some important area of TicketProf. And I think when it comes to the interpretation, you interpret the explain plan in the next session. So any question? Based on what I just did? Any question on what I did, what I just explained?
Please, I have a question.
Yes.
Yeah, I seem not to understand the difference between the secret trace file and the real-time monitoring.
Now, one is just live. Real-time ticket monitoring just gives you live information. So while the secret statement is still running, you have real life. Okay, you can see in live how the secret statement is running, and you can identify the plan. You can get the plan of that secret statement while it's running. If the trace file, the secret statement doesn't have to be running. Okay, it should not run. So meaning, for you to use secret trace and TicketProf, you have to enable tracing first. At least even for the previous one, for this one, we're even able to just get the SQL ID and get the plan. But for SQL trace, you have to enable the session. If the query was running, right, you kill the job. You kill it and you enable the tracing. Once you enable the tracing, now you run the query again. You know that, okay, it can stay the stock. But once you run it again, it will generate a trace file. That trace file will go to the other log location. You can now use TicketProf to easily read those trace files. Okay, so that is basically how it looks like. So One is the real time, another one, even though it provides more detail than the real time, but you have to stop the query. Okay, stop the query from running, or enable the tracing and run the query again in order for you to get the details and to get the plan of the query. Yeah?
Okay.
Question.
Yes.
What will happen if you enable the tracing, for example, and then you don't disable it?
A lot of trace file will be generated. That means if you enable tracing, every single sequence statement you'll be running, right? There will be a trace file created. So it means that location can get full. And if that location gets full, I have performance issue. If the mount point is full, it means that the alert lock will be affected. And definitely the database can even hang because there's no more space in that mount point. That's why we say that when you enable tracing, you run the query you want, and as soon as you are done with the query, you disable the tracing to avoid a lot of trace files to be generated. Does that make sense?
Yes, sir.
Okay. So let's jump to access part. What is basically an access path? This is actually what you can find on an explain plan. Once you generate an explain plan, you can find the access path from the explain plan. Okay. So whatever you guys okay, we generate. If you want a bigger plan, you can do it from. You can use a bigger query or a bigger table to get a bigger plan. So an explain plan just determine the access path the optimizer is using. The access path the optimizer has chosen for your query. So whenever you run your query, the optimizer will try to check all the indexes existing, and you try to compare the cost of using these indexes and the cost of going straight to the table. Okay, so and that is when the cheapest option in terms of memory, CPU, and I/O, the optimizer will choose the cheapest option. So the table access full is used whenever the optimizer decides to go straight to the table without using any index. Okay, so without using any index. So most of the time, that is what will be used. And it is highly used, mostly used for small tables, and also for tables with low, for columns with low selectivity. Let's assume that you use a query like this one. Let's assume you use a query like this, the last one. And this column called department ID is not highly selective. That means what? That means this column has a lot of duplicate. If this column is not highly selective, the optimizer will more likely use perform a full table scan. But if this column is highly selective and an index has been created on it, the optimizer may use an index. Okay? And in any case, any situation, the optimizer will always calculate and will pick the cheapest option. So that's why I made mention of low selectivity. Okay, that means if on the workflows I'm using a column like gender, it's a low selective column because gender, either you are a man or a woman. Those are the two options we have. Okay, so there is a highly selective column and there's an index created on it. The optimizer may still use the table or may not use the table, because in either case, we always try to calculate the cheapest option. So the second option is what we call table access by row ID. Whenever you guys see this option on a plan, it means that an index can occur before. So whenever you see table access by row ID, it means there was an index scan. Or in an exception, will be that you used on your query row ID directly. This is in rare scenarios. So meaning that the users knows the row ID and the person is querying the row ID straight. In that scenario, you may have this access path, but most of the time, unless you specify row ID on your workflows, that means somebody comes and do where department equal, or maybe you put where row ID equal, you put the row ID. That means you know the row ID. In that rare scenario, you may have this access path. But if you don't do that, by default, most of the time, if you see this access path, it means that an index can occur earlier. Why? Because I told you guys that whenever an index is used and some data are still to be retrieved from the table, what the server process will get from the index is the row ID. Once the server process can get the row ID from the index, then it will go down to the table blocks in order to retrieve the exact rows. And that is what can cause an index the table accessed by row ID. Okay, so I think we all know this. So let's assume this is an instance. And in an instance, I will focus more on the buffer cache. And we have a query, a user that's trying to access the database. Okay, we have a disk here. We have a block here. We have another block. Let's assume a user is trying to get some data. And maybe the table has 100 blocks. If, for instance, the memory buffer cache has 60 of them, and the disk has 40 of them, once you come, because the query, maybe the select needs all the 100 blocks to perform a full table scan, it means that some data are found here, and the server process will also come here on the disk and copy the other 40 blocks to bring them to the memory so that you can make 100, because we need 100 blocks. The optimizer is saying that the table is spread across 100 blocks. So if the memory has only 60, then the additional 40, of course, should be found on the disk. So the server process should go on the disk and grab the additional 40. So a full table scan, this is how you occur. So once you grab the 40, now you will now look now for the data in those 100 blocks here now. It doesn't look for the data right it is on the disk. It doesn't do that. While the data is on the disk, it doesn't look for that. So it has to bring the blocks to the memory first before it scans those blocks, before you try to identify the data on those blocks. Okay? And that's what we call full table scan. All the blocks that contain the rows of the table are red. But with an index scan, let's assume I have index blocks that are different from the table blocks. Let me take another design. They're a bit different like this. So it means that if the optimizer decided to perform an index scan, the optimizer, the server process, the index blocks, try to identify the row ID, then go to the table blocks to identify the matching row ID. 1 second. So that's basically how index can work. So it means the index blocks has to be read when they are brought back to the memory. Now, if some information are needed from the table, now the server process now we go to the table now to grab, the information. As I explained, so using a raw ID that was retrieved from the index, you can now go to the table and get the row you need. Okay, that is why I call it table access by row ID, because an index has to be read, the index has to be read first before the table is read. It is like you have a book, you go to the index page, you identify the page you are looking for. Now you go back to the content of the book itself, and you find it. So that means you have to go first to the index, then you come back to the table. Okay, and whenever you come back to the table, we call it table access by row ID. The access part now will be table access by row ID. But now, when you are using the index, the access part can differ. So it can be all these options. Okay. So when it comes to index access part, we have index full scan, index fast full scan, index range scan, and index unique scan, and all those stuff. These are just few of them, not all of them. You guys should know that. So whenever on a query, we are using maybe an order by or a group by close. Okay, let me stop here first. Any question about this one? Any question about what I just explained before I go to index?
I don't really get it, the second one, the table access by the ORD. I don't really get it.
So that most of the time we hardly see this one whenever index scan occurred earlier. So it means an index was used before the table is used. So meaning your query comes, the optimizer say, okay, I have a path. There's an index that can give, if you use this index, you can have a better, okay, the optimizer will create a better execution plan using the index. So when your query is coming now, the optimizer say, okay, this is the plan you have. You have to go to the index first before you go to the table, because the index will help you to easily access your data. Okay, so when you go to the index, you are doing an index scan. And after the index scan now, if the index cannot provide all the informations, you have to go back to the table. And I think I provided, I gave you guys a query like that. Let me see. This one or this one? And I think I have a query. Select first name, last name, social security. An example, okay? From out.emp, where if this column exists there, I'm just taking an example, where source, no, let me not take social security. Let me not take social security. Let me take where last name is equal ABC. So let's assume now that I have an index created on last name and social security. Let's assume I have an index created even on both. It can be one of them, one of the column, or both, okay? So the optimizer, for instance, decided, okay, let me go to the index. Let me send you to the index before you come back to the table. So when you will go to the index, you will be able to find the last name and the social security because the index will have the value of these columns. But now, the index doesn't have the value of first name. So that means you can get last name and social security from the index, and you have to go back to the table in order to get the matching information for last name and for first name, sorry. Because the index doesn't have it. So now, whenever you are going to the index to get the data, we call it an index scan. We have multiple options of index scan that I will explain. Now, once you get what you wanted from the index will give you last name and social security and also the row IDs of all the matching values. Now, when you come back to the table, you are looking for now the whole IDs in order to find the first name because the index will not provide you the first name. Okay, so that is whenever you leave the index to go back to the table to find additional data, we call it table access by row ID. Does it make sense?
Thank you. Makes sense, man.
I have a question.
Yes.
So where is the table scan being performed on the disk?
No, the disk doesn't do anything. On the regular servers, okay, the disk doesn't perform any computation. So you have to copy the blocks to the memory before you do whatever you want to do. So that's what we call cache miss. But if you want to do even a select statement, you cannot select while it's still on the disk. It has to be retrieved from the disk to the memory before the select statement is executed. Okay?
Okay.
This is what happens on a regular server. There's a type of server we call Exadata server, Exadata machine. Okay, that is not part of this program. In that Exadata machine, even the storage can help. Okay, some statement. If you have a big select statement, instead of doing it on a memory, it can take place straight from the disk. That is something else. Okay, but on regular servers, all those stuff takes place, all the update, delete, select, whatever operation you are doing, everything takes place at the level of the memory. So if the block is on the disk, it has to move to the a copy of it has to go to the memory before the change is performed, not straight on the disk. All right. So another access path. Now, these are now index access path. It means that in these scenarios, one or multiple indexes were read. Okay. So that means whenever you see each of these paths, it means an index scan occurred earlier. So a full scan just means that maybe on the sequence statement you added an order by. This is in most of the time, not always. Added maybe order by or group by close on the sequence statement. So meaning maybe you have a select statement like this one, and at the end you put order by. So you want to order the result you have by maybe first name or by salary. If I want to order something by salary, it means I'm going from the least paid employee to the highly paid employee, right? So that is what it means, order by. So you can decide to order by default, it is order by, it's order in an ascending order. You want to order in a descending order, you specify desk. So it's just basically something like this. You specify order by, maybe you specify salary. Whenever you add this order by close, and the column you specify here is index. So if you use order by, and the column you are specifying after the order by is indexed, more likely the optimizer will choose the access path will be full scan, index full scan, more likely, okay? We have order by, we also have group by. Make sure the column is an index column. If this column is not indexed, no, a full table scan will take place. So that is basically what I can trigger, you know, what can cause an index full scan. An index fast full scan occurs whenever all the columns you are looking for are found in the index. All the columns you are looking for are found in the index. Let me just show you what I performed earlier. So it means, for instance, for this query, if I put maybe order by first name, no, last name, it can perform a range scan. It can perform a range scan because I'm ordering by, I'm issuing order by, and the column is an index column because there's an index created on the column. It may perform a full scan, okay? But let's assume now that on this same query, let's see what's going on. On this same query, I remove this one. Tell me what will happen. What do you think will happen if I remove one column?
Both columns belong to the index. So it's an index full scan.
Yes, you are right. Will the server process go back to the table to retrieve the data?
Yes. Let's go straight to the index.
Who is saying yes? Tell me, please. Give me more detail about why you say yes.
I said yes because from here, the first name you just removed will not be traced from the index. So it has to take the information from the index to go get the full information from the table.
Which information it has to get from the table again?
Because the first name is not in the index, I think.
Yeah, I already removed first name. I don't need the first name anymore. I remove it. So the query is now select last name, social security from whatever. There's no more first name here. Right? So what's happening is that if you go straight to the index, it won't go back to the table because whatever we are looking for, last name, social security, These columns are indexed. Last name, social security, they are indexed. So it means we can get the result straight from the index. We don't need to go back to the table. We went back to the table before because we had a column here, first name, and we could not get the result from the index. But since now the index can give us everything, the index can give us the last name and the social security, meaning I can just grab the result from the index and just send it straight to the user. In this particular scenario, the access part will be fast full scan. Fast full scan because everything was found on the index. You don't need to go back to the table. This is what it means, fast full scan. Range scan mostly occur whenever you have this. You have a letter that starts with, it's not just A, okay? Just a letter or just some characters, and after you put the percentage after that. So whenever you use this, call it, I think it's wildcat, something like that. Whenever you use this, automatically there will be a range scan. Whenever you use these operators, and in few scenarios, whenever you have order by, can also close a range scan. For few scenarios. So that's why you cannot know exactly which one between range scan and full scan can be. It depends on how the query looks like. So order by can give you the full scan or the range scan. So range scan just means you are retrieving a range of values from the index. Okay. So if somebody is using this sign, it can lead to a range scan. Unique scan means only one value has to be returned. So whenever you run a query, if in the where close, this column, if in the where close, the column specified is a primary key column, then there will be a unique scan. Why? Unique scan means only one value will be returned. And we all know what is a primary key. A primary key column is a column with unique values. So all the values on that column are unique. It means that if I use the primary key column and I use the equality operator, 100%, I will have an index unique scan. Okay? Because there should be one result returned. An index join scan occurs when there is more than one indexes involved. So it is like, maybe you have, let's put back our first name here, and maybe you have index number 2 created on first name column. So that means maybe the optimizer may decide to use both indexes in order to return the result to the user. In this scenario, we talk about index join scan, because maybe you specify something like this. In most scenario, a join scan will occur when you have a query like the one I'm going to write now. So let's assume I have a query like this, where last name equal and first name equal. So meaning that when the optimizer will look at this query, you will see that the first column after the where close is indexed. The other column is also indexed. So if the optimizer decides to use index 1 and index 2, it may perform a join scan, because the result of this query is coming from from more than one indexes. Okay, in this scenario, you can have a joint scan. Specify here belong to two different indexes. And the other one, index organized table, I think I explained that. It means that tables are organized as indexes. So tables are already sorted as indexes. And it is, you will see this access path whenever you're using index organized tables. Okay. So let's take a short break. Okay. Come back and proceed with hint, and then we can go to, I'll just show you really quick how to get those plans. Okay. Let's take 15-minute break. 15 minutes. We come at 7:15. We can proceed from the hint. Okay.
Okay.
All right, we are back. Okay, let me finish with hint, then we jump to something else. Okay, so hint are just if you want to force the optimizer to use a particular access path, you can use hint, okay, to do that. Okay, remember somebody asked me what is first role, all those stuff. You can decide to add a hint first rows. We call it hint for optimization. So by adding this hint, we are asking the optimizer to return only the first 10 rows of this query. You can have hint. Basically, this is how the syntax of a hint looks like. We put a /, we put star, we put plus, and whatever you want to put, you put it in the middle. Okay, you put the particular hint, whatever you want to use, you put it right in the middle, and at the end you still put a star, you put a /. Okay, so this is the syntax. The hint should be right after the select. It should not be anywhere else. It should be right after the select or right after the update or whatever. Put it right after the select statement. And if, for instance, so it's just basically what it means. And as I think I gave you guys the list of hints, useful hints. Okay, you may not know all of them. Okay, but this list is not okay. It's a quite good list. Okay, give you the type of hint you can use. So this is the one I explained. We have some type of hint here. I have a hint for indexes, a hint for join methods, hint for cluster tables, hint for parallel hints. A lot of type of hints. Okay, you may not know all of them. I may not use all of them. Okay, so basically, whenever you are using a hint for your query, you are trying to force the optimizer, but it's not 100% guaranteed that the optimizer will follow what you put here, okay? If the syntax is wrong, if maybe instead of putting employees, you omit maybe an E or a letter, the optimizer may not use the hint, okay? Well, even if you specify an index here, the syntax is good, the optimizer will still try to compare that with all the plan. So the optimizer may use it or may not use it. The hint should be reasonable. So make sure that you put it right after the select and make sure that the syntax is good and all other stuff. Okay. So we have multiple types. This is, for instance, a full table scan hint. So that means you are asking the optimizer to perform a full table scan. You don't care about the access path is actually using. You're asking the optimizer to perform a full table scan on the table called employee. Okay. And yeah, so basically I give you the list of in. Another one is SQL plan baseline. Basically, it is not enabled by default, okay? Basically, whenever a plan is created, you guys know the plan, okay? Whenever the optimizer creates a plan for you, for a query, you just give that plan to the query, and the query goes straight to the buffer cache or to the disk, okay? And a copy of that is stored in the share secret area. That's what you guys know, okay? But whenever we enable SQL, whenever we create what we call the baseline just helps you, it helps Oracle to avoid performance regression of queries. Let's take an example. Let's assume today you run a query, the optimizer create a plan for that query, and the plan is stored in the baseline, in the share secret area, sorry. And after a couple of days, the plan is flushed out because it's old. You run the query again, the optimizer will try again to create another plan, okay? Because it's no longer in the share secret area. So you go again to hard passing. Maybe the new plan is creating is even worse. Okay, so and with the baseline, you can decide that for a particular query, you can create a baseline. So that baseline will contain acceptable plan of that query, good plan of that query, such a way that the next time whenever the optimizer is creating a brand new plan for that query, the optimizer itself is going to compare the new plan it just created with existing plan in that baseline. So it's comparing them. If the baseline doesn't exist, automatically the optimizer will use the new one, the new plan it just created. But if the baseline exists, the optimizer will try to compare the cheapest option. Okay, which one is better than which one, and that is how you work the baseline. So the baseline, you have to enable it. Okay, if you want to do it automatically, there's a parameter you need to set up, automatic capture SQL baseline. If you want to do it manually, you should use what we call the sequence plan management package. And I think I have it somewhere here. So you want to capture plan. You want to capture the plan of a SQL statement and store in the baseline automatically. Just run this command at a session level. So whenever you run this command, it means that every single SQL statement that will be run twice automatically will be stored in the SQL baseline automatically. You can use this view to see all the baseline. So this is how you can do it automatically. Make sure you turn it back off to false. Otherwise, even if you don't want the plan of a query and that query maybe is executed twice, it will also be stored in the baseline. So when you turn this one to true, immediately you ask the user to run the query 2 times, or you run it yourself twice. So once you run it, automatically it will be stored in the baseline. So this is one of the way of capturing the plan and storing them in the baseline automatically. The manual method is to use a package called GBMS SPM load plan. So whenever you use this package, you need to specify the SQL ID, the plan value, the SQL handle. The SQL handle is, an identifier that you can find whenever you are using this view. Whenever you are using, you are querying this view, you will see that every single SQL statement has a handler. So once you can specify this matrix, you just run this package. Once you run this package, it will load the plan in the baseline for you. Okay, so it's very good because let's assume why is it useful? Let's assume I'm upgrading the database to a higher version. With the baseline, if the version where I'm going to, okay, if where I'm going to, the performance of my query degrades because of the baseline, if where I'm going to, okay, the new plan the optimizer creates for my query is worse than what was there before, right? Then Oracle will pick the best one from the baseline. So it just helps to reduce performance regression, maybe due to an upgrade or due to a change on the system. Maybe some parameter were changed or something was changed. And because of that change, the performance of my query can be affected. Okay, so the baseline will prevent that from occurring. So whenever the new plan will be created, the optimizer, in addition to creating the plan, we compare the new plan it just created with all the existing plan in the baseline. So if the plan in the baseline are better, then the optimizer will not use the new one, okay? We just focus on the one in the baseline. So that's basically what it means, okay? So that's how useful it is. And when we get to upgrade, I will throw more light on how to fix performance issues after an upgrade with the baseline. Any question? Okay, so I'm just trying to run all those stuff we talk about. So I'm using a server. Now moving forward, you guys may have more than one. software installed after we do Oracle 12c. So meaning for now, maybe most of you have just 11G release 2, okay? And now we will do 12c, so you will have more than one software installed on your host. It means that whenever you want to connect to database, you will not just go ahead and do .space or .env, okay? Because now you have more than one environment. You have now more than one environment. So you have to make sure that you are connected to the right environment, okay? So now, okay, you will see that you have now more than one batch profile, okay? Maybe you have a batch profile now, maybe you guys have only this one. But when we get to set to some projects, you will have more than one batch profile. So you can have a batch profile for 10G, a batch profile for 11G, a batch profile for 12C. The 10G one, I will not work on 10G with you guys. I don't want you guys to waste time on 10G when we are doing the upgrade. 10G is already deprecated. We will not waste time on, because we have a project called upgrade. An upgrade consists of upgrading a database from 10G to 11G and from 11G to 12C. And sometimes a lot of people are stuck just at the level of upgrading from 10G to 11G, even though the procedure is the same as it is to upgrade from 11 to 12. So, and I don't want us to waste time on something that's already duplicated. So for you guys, we will start our upgrade on 11 and we'll go to 12. I don't want us to waste time on this. So let's assume you have a 10G software installed on your virtual, okay, on your server, meaning that for every single software you have, there should be a batch profile, unless you want to use functions. So meaning that for 10G, there's a batch profile. If you open it, you will see the way it looks like. Okay, you will see that, okay, the Oracle home now is 10G and so on, okay? So, and 11G release 3, 11G release 2, and 12C. So that means if you want to connect to 10G now, to the 10G environment, okay, you put dot space, you just specify the batch profile, and you are in the 10G environment. In the 10G environment, okay? If you want to go to the 11G, you do the same. Dot space, specify the batch profile of 11G. You are in the 11G environment as well. Now you see it's 11G. If you want to go to 12C, you do the same thing, dot space, the batch profile, you're on 12C environment. C, 12.1. So most of my demo, even all of them will be on 12. So it's the same thing, okay? So since I'm on 12C now, I can do what you guys know, okay? You guys know all this. So dot space or env SQL plus assist.VBA. Okay, this is the schema I advise you guys to use, okay? This schema is a quite big schema, okay? And you can change the password to, you know, to is locked. Whenever you just created a database, all accounts except system and sys account are locked. So that's why you always have to. So if you want to connect to this schema, okay. Okay, this is from SQL. And if it's from SQL Developer, okay, SQL Developer, I recommend you guys to download SQL Developer 18, see, 18.2 from Oracle, 18 and above. Okay, It's also easier to do that one. Okay. I think I in the morning I showed that to morning class. www.oracle.com. Now we have the 20C available, so you can use the latest one. So when you type www.oracle.com, it brings you here. You go to resources. It's still loading, that's why. Okay. Let's go. Resources. When you go to resources, software download. When you go to software download, you see developer tools. Developer tools, you will see SQL developer. And I think it's the 21, so it's even more advanced. You can choose the second one. If you're using Windows 32 or you're using Mac, you use this one. So you just click here. I think it asks you to log in, right? And it can ask you to log into your Oracle account. Okay, you guys took the OCA or the SQL fundamental. So you will log in and it will download for you. That's how easy it is. So once you download it, you unzip, you install, okay? And when you open it, it will look like this, the welcome page. You want to add a new connection. Make sure there's a two-chair connection created. You guys know how to make two-chair connection. That is GB2 exam, okay? So you guys know that you have to update the chain in the Aura. So add the database in the chain of Aura. As I did, the database on the chain in the Aura, class 26 is there. Make sure you're using the right listener port. How will I validate my listener port? I first of all have to know all the listener running on my server. Okay, grab TNS, and I should see their home where they are running. So we can see that the listener running on 12C is called listener 1, but there's another listener running on 11.203 called listener 2. So meaning if I want to see the port, I should check the port of listener 1 because that is the one running on 12C. So that means if I'm checking listener 1. For now, you guys have maybe one listener, I don't know, but that's how it is. And you can see the port here. That is why I put 1501 because my port is not 1521. My port is 1501, okay? And that is why on my chain in the Aura, it's 1501. So once you can make the two-chair connection, then you can connect to SQL developer. So you just come, you click on plus, specify the connection name. Just assume I want to connect as SH user. SH user, and I want to connect the data. Put the name you want here, okay? It doesn't matter. The database is class 26. The username is who? SH. Password, SH. Okay? If you want to save the password, you save. Because SH is not an administrative user, the type of connection specified. If you have a connection string, that will be specified here. But since we are using a basic connection, if you have SSH, you have a key to connect, but you need to download that key from the cloud. That is basically for those who are connecting from a database running in the cloud, especially if I'm connecting to a database on Oracle Cloud Infrastructure or whatever, SSH can be used, okay, to do that. So, but for our option, for you guys, just use the basic, okay? Just keep as default. If you are connected as 6DBA, as 6 user, you can change to 6DBA. But any other user, maybe you are created, yeah, I'll talk about some of other users when we do data guard, or maybe 6 backup because we're on 12C and so on. We talk about this these privileges on 12C. But this user is SH user, so it's a default user. You don't need to, you can set the connection to basic, okay, as it is. You specify the host name here. The host name is your server, okay? You know how to get the host name on any server. If you are here, you just specify a host name, okay? And this can be your host name. And an alias of this host name is like this.
I have a question, please. What is
Yes.
SSH?
Secure SSH.
Yes.
It's a way
Yes.
of. It's just a way of connecting to the to a server. Okay. If you want to connect to a remote host, you need SSH to do that. Okay.
So it's only for remote connection.
Yes, remote connection. If I want to connect to your server right now, I can just exit from here and do SSH and I'll put your server.
Oh, okay. I got it.
Make sense?
Thanks. Mm-hmm.
So put the port here. I say our port was 1501. And I put the SID here. The SID is class 26. And test the connection to see first if you can connect. Okay, network adapter. Okay, I put the wrong host name, sorry. So again, 367 was the host name. Okay, so because the right. Okay, let me test again and see. Now I can connect. Okay, it's success. If you want to save it, you can save. If you go here, I'm on the list of the save connection, so that the next time you just come and check. This is what we call the connection string. Let me show you. This is what users can use to connect to the database. Maybe this one is not that clear. Let me use this one. So this is what you can use to connect to the database directly. So now you can just connect, okay? What's wrong? Okay, you ask the password, sorry. Since I click on the connection, you can save the password you want to, okay? Once you connect, you open a page for you, okay? You open it, you create a new connection for you. Where is the connection here? Gaetan class 26. Oh, no, SH class 26. So this is the new page, okay? So once you are connected here, you can now issue any query you want. Any query you can issue on body, you can issue here as well.
Typo.
Oh, sorry. You can see all the tables of this, okay, of this user. I recommend you guys to use a table like sales, because if I want to use sales, select count, okay? Count of cells. Let me see the count. How many rows? You see, it has 918,000 rows. That's why I told you guys, those who are trying to do presenting, partitioning, indexing, whatever, you can even increase this one to millions of rows so that the testing will make sense. So it's a quite big table. It's good for. Now let me generate explain plans. As we said, I want to take a query that makes sense, that is not that small. Okay, we take this query because it's not that small. Okay. In the morning, I had some challenges because the database I wanted to use, somebody accessed my database and performed some messes. So it could not be, I had some issues and I had to use some basic tables to do my testing. So this is an example of a query. Let's just use this query itself. Select whatever, okay? So this query is a SQL statement that helps to get results from three tables, customers, products, and sales. It's like you join them. Please don't worry about this one yet. So this is a quite big query, Okay, it can take some time. Okay, this one took just 1.2 seconds. It's quite long, okay? Because normally Oracle to execute queries in microsecond, okay? So it's quite big. So if you want to use explain plan, you just put, as I said, just put in front of the query, explain plan for, and that's it. Once you put explain plan for, you run it. We just give you explain. See? Just give you explain. If you want to run the same on body, sorry. I did not copy the entire Control C. If you want to run the same thing on body, also give you explain. And I say that when you run it, right after that, you should run, select star. This is what I said, right? For the explain plan, if we all remember, which one was it? This one. I said after you run explain plan for, you put a query. At the end, you have to specify select star from. Why is it saying this? Why is it wrong? Oh, okay. I will. Maybe this is a screen issue. Okay, I will see. So after you put the explain plan for, you need to specify, select star from. Okay. You can run it either on body, you get the plan. It doesn't look good, right? Or from SQL developer, get the plan. So this is an example of plan. I don't know where this thing is going. How can I remove this thing? Oh.
Someone is probably writing on the screen.
Yeah, and the person does that frequently.
Yeah. Excuse me.
Let me see. Okay. Yeah, stop. Maybe it was a Zoom stuff. Yeah. So.
No, someone was probably writing.
Oh, really? Oh,
yeah.
Okay. Okay. So, this is an example of plan. Okay. I will show you how to read this plan next class. So, this is how I was able to get the plan. So I'll issue this command first, then I just issue select star. So this is an explain plan. This is an explain plan. We interpret this. So I want you guys at least to be able to run something like this. Just run, okay? That's quite good. We talk about this one next class. The other way of running the explain plan, I said that the auto trace, okay? You can set auto trace on. So let's assume you want to set it here. SQL Developer is quite good because it's a text. You can edit. You can change right from here. It's okay. It's not like body. So let's assume you want to set auto trace. Okay. If you do like this, you are setting. On SQL Developer, you cannot do that. You cannot do this one. Okay. If you want to set auto trace, I will show you the button. But from body, let me see. You can set the trace. When you set the trace, you run the query. Let me close the other one. I don't know why I'm having this one. I don't know why I'm having two SQL developers. Let me close one of them. Okay. I don't want you guys, I will show you guys this. Okay, so I don't need that now. Why is it doing this? Anyways, okay, so I will tell you why on SQL developer you cannot have that one. So if you do this, oh no. When I issue, normally this one. Now let me see. Okay, let me try different. I'm still putting explain plan. Or let me see this one. Let me now put select and see. Okay. So the thing is, I was putting explain plan again. Okay. I did not pay attention to the query. So let me do the same thing on SQL Developer. Okay. On SQL Developer, I know the format is not that readable. I know why. Because let me see if I can affect the decision. Better? Yeah, it's quite better because we can see all the columns now. So yeah, we give you the plan. So with auto trace, you just set auto trace on. Okay, you just set it on. You have multiple ways of doing it, but make sure at the end you set it off. Otherwise, every single SQL statement you'll be running here, you have auto trace. On SQL Developer, you can just copy the query you want. Just copy the query. Copy up to here because I don't want the explain plan for. The part I copy, I will try to check auto trace here. There's a button, auto trace on SQL Developer. And I run it. And I click on the button, auto trace here. Now maybe they see it. Okay, let me remove this semicolon. Let me get the auto trace. And I can get the explain plan right from SQL Developer. Make sure you remove explain plan for. So again, I do this. You move your cursor, it will tell you what it is. Auto trace. Even the explain plan for command, you can see it here as well. You will put your cursor, it will tell you explain plan. You can say click and see the explain plan on SQL Developer. You don't need to type explain plan for. That's also another benefit of using SQL Developer. But now, the third option is the GBMS Explan cursor. I told you guys that this one is good, it's highly used as well, but you need a SQL ID. So it means we assume that the SQL statement has already been executed before. So this is our SQL statement that has been executed. Okay, let's execute the SQL statement. This is a query, and we need a SQL ID of this SQL statement. Okay, let me take this one. We need a SQL ID of this SQL. First, that's the first thing we need, right? So that means we can do select SQL ID, SQL text on $SQL, where SQL text like. If you remember the entire syntax, you copy, you paste. If you remember just a part of it, I can take maybe a part of the data like this one. It take maybe just let's assume that I remember only this part. So you can just run this command. It will give you all the SQL ID. It becomes complicated. Sometimes for some other users, they can use unique identifier to easily keep track of their SQL statement. But it's fine. So let me see. Okay, maybe I need to add more information than just what I have. And maybe let me even, okay, let me try again. Let's see. Okay, so you see now that it gives me one SQL statement. And this is the SQL ID. If you want to run the same thing on the command line, you can run the same query. Wow. the same query from the command line. Control C. It also give you a SQL ID here. Okay, one of these should be a SQL ID. You figure out one of these should be the SQL ID. Why is it different? Yeah, let me see. SQL developer is 0OUF. Okay, 0OUF. But let me see the syntax again. Let me make sure it is the complete syntax. Oh, C percentage. This is not what I'm looking for, because that is not the complete SQL statement. Why is my SQL statement? Because my SQL statement, okay, let me execute my SQL statement again. And let me maybe just copy this part. That's it. I don't want to. That was the wrong one, because I could see at the end a percentage. It should not be that. Control V. I now put a percentage at the beginning. I just put it at the end. Let me run it and see. Okay. Let me see the entire syntax. Okay, it looks even alike, the same thing. I ran it twice, so it's the same thing. And I can see that it goes all the way till, the last value. So this is the right SQL ID. So this SQL ID, now I will use it. I will put this query there. Okay. I will specify this query, and I will now replace this area with the SQL ID. Even on Poly, you can do the same, okay? So you choose the SQL ID, Control C, you put the code, okay? So once you get the SQL ID now, you can get the plan of your query. So you just need to run your query, get the SQL ID using select SQL ID, SQL text. It's still on the PowerPoint, okay? You specify either your entire SQL text or a part of your SQL text, and you just get the plan. So this one will help you to get an execution plan, more reliable than the other one. For ticket prof, whatever, the group that's presenting the spend plan, we do that, because we don't have enough time. And the last option is SQL monitoring that we do now, or run now. Because I said, even though we will not have the live information, but I will show you how we call SQL monitoring from SQL developer. Okay. Let's assume this is our SQL statement. Where's our SQL statement again? This is our SQL statement. And let's see the execution time. You see here is that's time. Before it took 1 second. Why? Okay, no. Let me not conclude. Control A. All right. So now it's 0.8 seconds. Because when you by default, SQL developer displays the first 50 rows. The first 50 rows. If you want all of them to be displayed, you have to press Control A to select everything. That's why you now saw that. See, here is 0.8 seconds. But initially I ran it, it was 0.1. And it told me fetch 50 rows. But this query has more than 50. You can see there that is more than 50. So if you want the execution time of all of them, you press Control A, and it will tell you how long it's taking. Okay. So if I want to see, because it's less than 5 seconds, as I said on the PowerPoint, it's less than 5 seconds. We may not see that from the SQL monitoring. Okay. So to go to the SQL monitoring, you go to Tools, you go to Real-Time Monitor. Once you go there, you specify the connection. Which one do you want to connect to? SH, right? You took, okay. I told you guys that it's a license pack. So it's telling you if it's licensed, you press yes. If it's not licensed, you press no. It's not like, I don't know, I just press yes, okay? But normally you should have the license at work. So once you run this, it will now display all the SQL statements that are running now. Wow, now we have only 2 running. In the morning, we had multiple, okay? Multiple SQL statements running. So here, for instance, it's displaying the only 2 queries running at this time. And they are completed. If they are still running, you will see here like loading. So this one is, this one is one job, it's another SQL statement. You can even see the SQL text. Yeah, let's scroll. You can see the SQL text from here. So this is not me. This is something running in the database. You can see $6 hours occupant. This is a job that is running. That ran maybe a couple of minutes before. So I don't see my SQL statement here because remember, my SQL ID is this one. I don't see that. The SQL ID of this SQL statement, right, is F8K. I don't see. So if I want to see that, I need to specify a hint. I monitor, put a hint, I put star, and I put /. Okay. And once I use it, I should run the query now. When I run this query, the SQL ID will change because the query changed. So meaning I have to update my SQL statement. I have to update. If you guys pay attention, let's update this one. Now let's run. Now, what do I miss? Oh, let me put the percentage at the end. Captures even whatever is after that. So let me now. Let me see. Why is it not? Is it different? Let me see. Let me run it again. Maybe. Okay, I'll run it again. Okay. Control A. Okay. Now let me run this query. Okay. So this is now the SQL statement here. The entire SQL statement with a hint. You can now see that the SQL ID is different. So now I can look for this SQL ID now. 9GG, if the SQL monitor capture it, because I added a hint, right? 9GG. You can see here that it's now captured. Okay, and you can see all the information, the number of IO requests, how many times I went to the disk, the text, and the plan is found below. So you can see here, these are the plan statistics. This is the explain plan itself. No, okay, this is the plan. 1, 2, yeah. These are other metrics. This is a small query. That's why the other metrics are not available. Let me take another one that ran longer, like this one, 34 seconds. No. Even this 34 seconds should display CPU. Okay? Because that one did not use some CPU, that's why, because you saw 00 here, that's why you could not see anything. But for this one, for the last two, you can see that some resources, the amount of CPU that was used, memory, the number of IO requests, and so on. Okay, even though the plan may not be in the plan table anymore or this video SQL plan, but at least we can see some metrics of my SQL statement right here. Okay, So for Chicken Prof again, why the other group will be presenting, okay, then we have to display how to use it. It's very easy as well. It's not complicated, okay? So I think for today we are done. Any other question? Any question?
Yeah. I wanted to ask, like, each time a statement is issued, it generates a new SQL ID.
No. Each time, if the SQL statement has not changed, the SQL ID will stay the same. Even if you run the SQL statement tomorrow, it will stay the same. Yes. Well, ID doesn't change.
Okay.
No, I think, excuse me, sir. I think his question is like, each time you execute, maybe you pass like a particular SQL statement. An SQL ID, like a unique ID, is being given to that SQL.
Yes. Every single SQL statement you execute, Oracle assign a unique ID to that SQL statement. But I thought that he was saying that if I execute, for instance, this SQL statement multiple times, it will come with different SQL IDs.
Yeah, that was my question.
Exactly. So that's why I'm saying, I don't care how many times you execute this, you will still have a unique ID. Okay? The ID will not change.
So I have a question.
Yeah.
What is the difference between an execution plan and explain plan?
I think I said that last class. Right? Who can explain the difference, please? Who can try? Who wants to try? I think I took some example last class, right? Just try. I can correct you. I can fix.
Baka, please help me, Baka.
Well, now.
So the explain plan is just a prediction. Yeah, okay. It's what the optimizer creates. That's the explain plan. So the optimizer will see your query, and based on the statistic the optimizer has in the data dictionary, the optimizer will create a plan for you. So you are not, the server process is not going yet to the memory, to the buffer cache. No, the server process is still there, waiting for a plan to be assigned so that it can go. So that is what the optimizer will create. And now, once the server process has the explain plan, it starts now executing that explain plan. It starts following that plan. Okay? So once it is following that plan, we call it execution plan. It's actually following the plan in the memory or from the disk. And the explain plan can be equal to the execution plan. That means the server process can look at that plan and follow it as it is and it gets the data without any change. But in some scenarios along the way, Oracle may have maybe some updated information along the way. And the plan the server process was following, it can start using a different plan. Along the way, while it was executing the explain plan, it used a different execution plan. Because Oracle along the way gathered up-to-date information or provided to the server process up-to-date information while it was running, okay? So that is why I say that the explain plan can be equal to the execution plan, and in some scenario, it can be different. And I think I took the example of White House for those who were in the class, and I explained that if somebody wants to go to anywhere, you type your map, your Google map. Your Google map will tell you how to get to the White House. That is the explain plan. You are not even driving yet. You are just typing. You just type. So that means if you follow what Google Map is telling you, you are just following the explain plan. Okay, you are performing the execution plan, but you're using the explain plan. You can follow that plan Google Map is going till you get to the White House. But let's assume while you are going to the White House, something happened. You maybe you meet an accident and something. The route you wanted to take is closed. What will happen? Google Map will find alternative, right? It will redirect you to another route. And that's in that scenario now, the explain plan, the original explain plan is different from the execution plan because you are not, at some point, you stop using the explain plan. And that's why we say the execution plan is more accurate than the explain plan. Does it make sense?
Yep. Thank you.
All right, no problem. Question? Questions? Okay, guys. So as we said, we meet Wednesday. I think it will be the same time. Okay. So please try as well to get SQL Developer. Those who know how to install it, help those who don't. Okay. And try to play with that. It's very good to play with SQL Developer. You can find everything here. You can create everything, table spaces, user. It's very easy. You should know that as a DBA. So start playing more with SQL Developer when you are doing performance tuning or a lot of stuff. Okay, play with this. It's a very great tool. Okay.
Hello, hi. I have a question, please.
Yes.
Yeah, but it's not regarding the class though.
Right.
It's regarding one of the certificates that we took. I just want more information. We took the OCP. I just want to know if you can give us more information regarding the training.
For the OCP, I did not take any training for that. I will just tell you what happened is sometimes you can get into a DOM file and the job you have to do yourself will be to validate the DOM file. So you have to sometimes test. The OCP, a lot of people failed it when I was taking it. Some people passed. I was in Texas. I came and found the DOM, but it was no longer valid because people were failing it, okay, whenever they were trying to take the test. It was failing. So what I had to do was to test most of them. Go to 12C because it was OCP 12C, create a database on 12C, and test some of the command, test some of the question. And yes, I was fortunate to pass it. But if you want to get an OCP certification, you will pass it, they will pass the certification, but you will not get the certificate. If you want to get an OCP certificate, Oracle recommends you to buy a course in Oracle University. And I can tell you that the course itself is not less than $3,000. So you may not buy it. So what you want to prove to the recruiter or whoever is that at least from the result you passed, but you will never get the certificate if you don't buy it from Oracle University. Okay, that's what I can say about it. So if you have a sample done from anyone, what we usually do is put multiple people together, they work together, okay? And so that I will give you the technique later if you guys want some technique, since everything is remote. If people are not too much afraid of Corona, you guys can make very big things. I can just guarantee you guys that. So if you guys want more detail about this one, just remind me after maybe next class or next week when we are starting. I will tell you how we have been handling such scenarios. Okay, I will give you more details.
Thank you.
All right. Okay, guys. Thank you.
All right, thank you, Gaetan.
Thank you to
Thank you.
Wednesday. Okay.